Is it working?
I'll just check on YouTube real quick.
Oh, I can do that. This on CTDS. My time. Oh, here it is. We are live.
Awesome.
Yes, it works.
Perfect.
Hmm.
I would be mad if you weren't subscribed.
I'm not sure if I am. Was I?
Let it be. Are we sharing in the correct format? I just need to double check just to be sure.
Okay. I'll try with my phone. Let's see what's happening.
Okay, for
Chai
some reason
time.
there's this like inception happening.
Inception.
Can you like open a
Oh,
tab?
yes, it is happening. Okay, that should be fine, I guess. Let's see.
I think this is fine now.
Wait for it. Oh, yes. Okay. So I can't be in the same tab. That's when things go bad. It looks like there's some lag between what's happening here and then what's being shown on YouTube. So I think there's a few seconds lag.
Yeah.
Okay.
Okay, like if as long as you're sharing, it should be fine.
Yeah. So then again, I need to look into can you check the stream quality? Because I think what's happening is we can only be 720p and not really 1080.
Yeah, that's because I
So,
can't pay. I'm quite broke
okay.
right now, so I can't pay.
That's
No,
okay.
they charge you for a premium StreamYard currently.
I see. Okay.
I
All
think this
right.
should
Let's
be
do it.
fine.
Do you want to tweet about it?
Yeah, give me one moment. What's the exact name of the competition?
SIIM.
Yeah, I'll just copy paste.
Hmm.
Okay, I've tweeted. Let's see.
Okay. Let's.
Yep, it's taking me to the right thing. I
I
think we said.
to start an impromptu. Nice. Okay, let's do it then.
Awesome.
Cool. So this is our first live stream. So people, if you're there and listening to us, be kind to us.
Yeah. And for some context, Aman has just won a bronze medal. Congrats, Aman! And like I was just chatting with him, and I was curious just to learn about this competition. So he said, "Why not live stream and learn about it together?" So that's what we are doing. We're just like looking at solutions, and we're just like going through them. Essentially, Aman is educating me about this competition because I don't think I even made one single submission to it.
SIIM's being really modest by saying that. But I think it's more of a team effort. But I guess the idea here is just SIIM and I are probably going to have a chat with each other, and we're going to have a look at the top. Because I essentially one thing that one of the Kaggle grandmasters told me, sorry, the Kaggle master, Dr. Habib. So if we go DRHP, I've mentioned his name so many times, but this is him. He's currently ranked 238, and I was just having a chat with him, and I was asking, "Oh, what do you do once a Kaggle competition finishes?" And he told me that the one thing he does do is that he will go through the discussions. He will have a look at the top solutions, and will try to basically he'll try to replicate some part of that solution. So I guess that's what we're going to do today. Another thing is, I guess, that's the main thing that we want to achieve as part of this live stream. So I guess Sayam, it's probably gonna be. I'm just gonna assume it's you and I. I think
Yeah,
that's the best way forward. So let's just go and have a look at some of the solutions. Okay. So let's see. So leaderboard. Okay. So there's the highest score is 0.635. So for context, same. Have you looked at the competition? Do you already know what's part
not
of
at
the?
all. So this is just like my first view. Total, like I'm totally an outsider to this one. I know like
Okay.
it was an object detection one, and like there were X-ray images. That's all I know.
Okay, great. So I'll give you some context. Basically, you have X-ray images in your data set. So if you go in data set, it's not even X-ray images, it's X-ray DICOMs. So if you
Hmm.
go in, you'll see there's directories, and then that's like a study series, and then it's called a SOP. So in medical, actually, I think I should give me 1 second. I just need to duplicate my screens so I
Sure.
can try and. What happens if I duplicate my displays? Keep changes, keep changes. Oh, that didn't let me do it. 1 second. Duplicate, keep changes.
Shivani and Akhilesh are congratulating you from the chat.
Oh, thank you. Is this still, can you still see my screen?
Yes.
Okay, nice. So let me just close this and we go to OneNote. Uh, don't worry about that. Let's go
Yeah.
to,
Nothing suspicious going on there.
no, nothing suspicious. That's just the DETR paper reading group at Weights and Biases, but that's it. So let's create a notebook and let's call it Kaggle. Notebook with that name already exists. I'm not surprised. Where is it? Oh, here it is. Okay, don't worry about this
Nice.
one. That's in, and we're gonna go RS. And we're just gonna go COVID. Okay. So then with this competition, I
Hmm.
guess the idea was. So I guess in medical, what generally happens is you have. Oh, look at that! I'm just using my highlighter. So you have a study ID,
Hmm.
then you have a series ID, and then you have a SOP, which is I guess I can't quite remember the full. I can't quite remember like what the abbreviation SOP stands for. But anyway, so basically, look at it this way. I think my understanding is SIIM, that is you. You decide to get an X-ray.
Hmm.
That's a study. Okay.
Hmm.
So let's say you're worried that the with the all that smoke in Delhi, you just want to get your lungs tested, right?
Hmm.
So the problem is there's a lot of smoke in Delhi,
Right.
okay, and you want to get your lungs tested, right? So
Google
that's
says
my
SOP
problem.
is standard operating procedure for images, but I don't think that's what it is.
No, I don't think that's what it is called. It's more like a SOP instance ID. Anyway, that's fine. We don't need to worry about what it is. So
Okay.
so I guess this is the problem, right? This is what you want to get tested. Okay, so you want to
Hmm.
get tested that there's a lot of smoke and you want to get your lungs tested. You're just worried that all that smoke is not good for your lungs.
Hmm.
So this problem then becomes your study, right? So you
Yeah.
get a X-ray done. That's your pretty much your series, and then however many X-rays you get done, I guess that's what goes into your SOPs.
Hmm.
Similarly, let's say you decide to get a CT scan done, that becomes your second series,
Got it.
and then you can have a CT scan, as many CT scans as you have. So that's the idea, as I understand. I could be completely wrong. I'm not a medical expert, but from what I understand, I think that's how this works.
So the
Uh,
series ID determines the like number of X-rays. So like a patient
yeah,
would have multiple of those, and that's what
yeah,
like that's how we differentiate between them.
yeah, pretty much. So have a look. So there's like, because every patient is going to be a separate study ID, right? So we
Yeah.
have all of these, however many directories do we have? We have 6,024 directories, which
Hmm.
means that's how many patients in a way we have, or that's how many studies we have. And then this becomes my series, that is, this patient got my X-ray done, and
Okay.
then the X-ray is stored as a DICOM. So what's a
Hmm.
DICOM? A DICOM is just a medical way of storing things, and in a DICOM what happens is you have your DICOM, and uh, there's like you get a metadata with the image. So metadata like patient ID, uh, date when this DICOM was taken, the height, width, or what all that stuff that gets
Okay.
stored as part of this DICOM. Okay, so I guess then let's just start going through. So the idea. Sorry, I was introducing the competition. So the idea is for each study, basically all those 6,023, you have to predict 4 labels. Okay,
Hmm.
and then remember how I said each study has images, right? So each study has images inside. For each of those images, you want to predict the bounding box of COVID. Does that make
Okay,
sense, Ian?
it does.
Okay, let's see if I can. I'm just going to stop sharing because this I'm doing something that's related to work. I'm just going to fire up an instance. So just for privacy, I'm just going to stop sharing
Yep.
and I'll go GCP launch an instance.
I'll share my screen in the meantime.
Yeah, go for it.
For anyone who hasn't read this, like this was such an emotional winning solution because this person lost their family member and they've decided to like win it, essentially win a gold medal and pay tribute to them.
Yeah. Is that Shivam's solution?
Yeah. Oh, they've posted it.
Oh, they have? Okay, I think
Yes.
we'll start with that as the first. Uh,
Sure.
but I'm just starting that instance so I can then set things up.
So I think they've also posted
Um,
a kernel as well. That's awesome.
oh, nice. Let's have a look at that. I think that should be nice to look at.
So looks like they're using efficient debt. Uh,
Oh, okay. Efficient debt
have you
is
done
nice.
a reading group on this yet? I think you
I
have.
have a blog post on efficient debt.
Oh, awesome.
So you can go to my blog and you'll see efficient debt. Just search efficient debt and you'll see it there if you want.
I'll I'll look it up separately. Google isn't giving the best results.
Oh, it
Uh,
isn't?
no,
If you search efficient at PyTorch, that should work. But anyway, that's fine. I can do it. I have no shame with a bit of self-promotion.
it deserves that, so that's nice. I'll drop it
Oh,
in the chat as well
okay.
in case
I'm
anyone
all
is watching
set
and
up
not.
with my instance, and all I need to do now. All right, I'm ready to screen share
I'll stop
again.
sharing.
So let me go back to StreamYard and share screen. Okay, share screen.
What happened there? I think Aman dropped out of the call. Oh, you're back.
I'm in the backyard. Oh, sorry, I just closed the tab.
No worries.
As we said, it's our first time, right, Sam?
Yeah,
So
I've made a few videos, but zero live streams so far.
yeah, same. Okay. Is that can you check for me if that's working now? Oh, whoops.
Yes, I
Okay,
can. I can see the
should
Kaggle
work.
tab. Yeah.
Okay, excellent. All right. So all we have to do now is I can just see if that works. Fine.
You don't use Emacs?
No, no, I've just been on Vim.
I was trying to provoke you through that. That didn't happen.
Uh, okay, that should be the instance. That should work. PyTorch. Hmm. This would this will
We're in.
yes. We're in the instance.
So
Activate Kaggle. All right. Few too many. Take Kaggle.
What I'm trying to do lately is just
With
like use the
this.
Docker image because that's what they use for the kernels also. So like that's just more convenient because then I don't forget a package and then I don't have to leave the notebook every time I need to install it.
Oh, that's a good idea. Um, yeah, I don't know why I'm doing it this way, but that's just how I've always done things. So
Yeah, I used to do this, but then like it's annoying because I always forget one single package and then I have to quit the notebook, install it, go back.
yeah, that's a good idea. Okay, so we're in, and then this notebook should work. I'm just having the notebook open just in case we need to write some code, which I
Hmm.
don't think would be necessary, but just in case. Okay, all right. So let's start having a look at. Uh, let's start having a look at main things. First things first is like there's like this simple way of converting. So where is it? There's like simple from Kaggle kernels. If I go to that Kaggle kernel, actually, you can convert your DICOMs to JPEGs. So that's this really good, great kernel that lets you convert. So you can pretty much read the DICOM. You can just use the PyDICOM package, and then you can read the file, and then you can convert that to a JPEG using this whatever is mentioned in this kernel. So you can have a look at that. So with that being said, let's have a look at the discussions. So yeah, so anyway, so the idea was in your data set, I was going to show you path lib import path. Actually, fast or that work? Or I can go
You have
fast
the
here.
dataset loaded in this instance, I'm guessing.
I do, yeah.
Awesome.
I like to use the fast AI.
Hmm.
Get image
I
files.
see
It's
you're a
really
man of
handy.
culture.
I see. That's correct. So we're just looking at data set. Okay. And then what am I trying to do? I was just trying to see files equals get files, and then my path is dot slash train.
Hmm.
That should be my all my. Okay, that's fine. What else do I need? I need my extensions to be dot PCM. Let's see how many files we get. Okay, there we go. So we get all our
Perfect.
DICOM files, right? And
Hmm.
then if we, what else do we want? We want the parent from this. Would that work? If I do files.attribute.parent name list object parent. Okay. F.name for F in this. What does that give me? That's my parent. Okay. So that's
So we're
my
creating a list of all of the
series
patient
IDs.
IDs,
Oh no,
right?
this is series IDs. So see how my path is train slash study ID
Hmm.
slash series ID and then just my
Right.
stop,
Got it.
right? So I'm just getting because I'm going files.attribute parent, which means it's going to grab the parent, and then I'm
Hmm.
just going to grab the name
Okay.
from it.
Got it.
Actually, I can just use panda should already be in there, so I can just convert that to a series. That's just like the uh, actually let's just do it like this, and then I can say I'm not very good at this, but I can make do in a few steps instead of okay. So this just tells me I guess this is all I wanted to show. Like a person can have multiple x-rays. So person with this series ID went in and had multiple x-rays done, like 3. Then with this series ID he had 2 x-rays and then so on. Does
Right.
that make sense, Ian?
It does. It does.
Okay, so that's the difference between series and SOP. So let's start having a look at the discussions. So let's go for the 5th place
Let's.
solution. Was that
Yeah.
the one?
Yes. That was the
Yes.
one.
Yes, that's
This
the one.
is yeah Shivan's team.
Okay. First of all, I'd like to thank my teammates without whom this achievement would not have been possible. We merged on July 12th. We explored and implemented a lot of ideas. I would also like to thank Kaggle for this great competition, as everyone here was sharing discussions and notebooks. Congrats to all the winners. Trusting our maximized CV score worked once again for us. Oh, that's right. Okay, so they trusted their CV score, not the LB.
Interesting.
Most of our time was spent on classification models, which was the reason we secured a decent position on the leaderboard. Okay, that's interesting. So they spent time on the classification models instead of the detection models, and they did not use any external training data.
That's fascinating.
It is fascinating. Okay, so let's just. I guess would it make sense to keep documenting this in a some way like fifth place solution, like as a bullet points, did not use external
Yeah,
data,
I could do
or
that, but yeah, I could just
uh,
make a
or I
notes
could do
file.
it in Notion if you want, because then I think it will be
Sure.
handy. Or let's just keep going like this. Let's see. This is the thing with live streams. You're not prepared.
Yeah.
All the models were trained on the
We just had too
competition
much
data.
and just launched this. Anyways.
Yeah. All the models were trained on the competition data after removing the duplicates as suggested here. Okay, I didn't remove the duplicates at all. That's why I got
Yeah,
like
I was
the
going to ask you, did you spend some
no.
time on EDA or just modeling
Oh,
straight?
oh no, I didn't do much with this competition. I was just interested in like learning about object detection. Like I haven't spent time with object detection before,
Mm-hmm.
and for me, all I wanted to do was learn about Detectron, or learn about these detection, and then just learn about YOLO and be able to implement and train models using those
Makes sense.
libraries. And then what happened was I didn't spend a lot of time on this, but I did start like again, Dr. Habib told me is like one of the good Kaggle strategies is to start with the top scoring Kaggle kernel, and then you start making adjustments to it line by line. So I guess that's where I started. I started with the two main public Kaggle kernels, and that's how I started like tweaking them. But I did
Yeah.
not spend a lot of time. Therefore, I'm like ranked 131, I guess. Anyway, so this is why I want to learn because it's new to me. And that's the
Yeah,
idea
also
of like,
131 isn't easy, so you're just like
yeah.
really underselling that rank.
Oh, okay. Yeah. So let's see how what does it take to get a fifth rank as opposed to 131. So they did. I guess first thing is paying attention to what's happening. So handling duplicates on the train dataset. Our annotation team updated the labels for the test datasets, but the train labels remain the same. The test labels correct the problem regarding duplicates or extra images on some of the studies, which previously did not have bounding box information. Bounding box information is now provided for duplicates or similar images. I see. However, regarding the train labels, those labels were kept the same and not updated as such in situations. There are two or more images belonging to a study. However, in situations where there's two or more images belonging to a study, we recommend only using the labels for the image with the bounding boxes and disregard the other similar images. Ah, I see. Okay. So what they're saying is if I have a look at uh if
So
I
there are
have a look
multiple annotations for the same image. That's what that's discussing, right?
yeah, so if I have a look at these, basically they're saying like for this series ID, if there's three images,
Mm-hmm.
you can pretty much just keep the one that has the bounding boxes and disregard the two. Like this is what it
Interesting.
says. In situations where there's two or more images belonging to a study, which is this situation, right? Because in that case, it's two or more images. We recommend only using the labels with the bounding boxes and disregard the other ones.
Mm-hmm.
These duplicate images were likely not looked at by the annotators. Okay. All right. So let's have a look. So I have
Interesting.
my files right here. So I can just say file F for
So
F
the
in
other
files.
images don't have annotations. I'm just
F
curious, how
dot
did you
parent
use them
equal.
for your models then?
Oh, I didn't
Because
use multiple images.
okay,
Oh, let's see. Hmm. Oh, F dot parent dot name. All right, there we go. So that's my three files. So let's see. Possibly, I'm just gonna call them duplicates, I think, right? And okay, that's my duplicates. Then what I can do is I can import. Oh, PyDicom would already be a part of this because I am PyDicom. Let's just import it. Import PyDicom from PIL import image. I guess that should do. So I can just say DICOM PCM read. I'm just gonna have a look. Let's see, we're trying to work with this image, right? So let's call it
Sure.
path. So let's see if I do that.
Oh, so DCM read is just like IM reads, but for DCM.
Correct. So see how the DICOM now is this.
Wow. Okay. Yeah,
That's
I've
the
never
DICOM.
read DCM images, so I'm
Oh,
surprised.
okay. So if you want to get the pixel array, that's what you can do. So see that. So now if I take the shape, my image is actually a big one, 2800 by
Yeah.
3408. Okay. So let's check the shape for path in duplicates. I just want to check all the shapes.
Hmm. Should be the same, no?
It'll take a while.
I'm guessing.
Yes, it is.
Yep.
Okay, so that's the first indication that these three images are duplicates, right?
Right. Makes sense.
So I have my pixel array. So I can go, I should be able to go image from array, and then can I do that? Would that work? Let's see.
I think it should.
Oh, okay. So it's gonna show it now. Yeah, that did not work. Oh, because I did not do the steps that I have to do here. Let's see. Read X-ray. This is what I need to do. So let me do that there. Let me copy paste that. Read X-ray, PyDicom read file, return data.
What are we doing here? Reading the
Okay.
file, applying a filter
So
of sorts,
so it
or transform.
no, it pretty much, I can just say pydicom.read file. This is what I did, remember, pydicom.tcm read. So that's going to give me the same thing. I'm going to get my DICOM.
Mm-hmm.
Then if this apply void do it, I'm not exactly sure what it does, but I just see it converts things to a human friendly view. But I guess we could have just done DICOM.pixel array, right? We did here. This is just some fixing the data, like X-ray may be inverted. So this, if that's the value, if monochrome 1 is the value of this particular field in that DICOM, then you just invert it, and then you normalize. Okay.
Got it.
So I'm just having a look. Why is this not using the rescale slope? It isn't. Okay, so I'll just use this. Interesting. So if I can go read X-ray and I say my path, would that work? Well, it is not defined, of course. So
Apply
I can
isn't
just
defined.
say that, import that. How about that? Okay, see that? That
Nice.
works. Can I go now image dot from array, and let's say that work? Should, right? That should work.
Yep,
Let's see.
it did work. Yep.
Great. Oh, cool. There we go. Okay, that's way too big. So let's just do plot.im show. That should make it smaller.
You need to add the inline. Okay. No.
Okay, and I can just say cmap equals bone. That make things a bit nicer.
Could you
All
please
right.
zoom in a
Okay.
little?
Yeah. Is that better?
Yeah.
So let's just do this thrice for path in duplicates. Let's see what that gives us. Do we get duplicates? Oh, it didn't. It just said, okay, there we go.
Give it a
That's my
second.
first image. I did a mistake, did I? Okay, I know what to do. Let's just say have data. I'm just gonna make a ugly hack because who cares?
Yep.
Right now, we just trying to, so that becomes my image, and then I can just say plot.im show image. Oh, actually, x. And that. Okay.
Hmm?
And then this can accept an x. Sorry, what does it say? Oh, okay. X equals none. So I can go fig, actually axis equals plot subplots. Let's say 1 row, 3 columns, and 1. What does that give me? Does that give me my axis? It does.
It does.
Cool. Uh, Actually, let's go 3 rows, 1 column. That still give me my axis? It does. And then I could have just said fixed size equals, let's say, 15 by 8. Okay, nice.
Yeah.
So all I want to do now is for path, comma x in zip duplicates. I'm sure there would be a better way of doing this, but please don't kill me if I'm doing it like this. Then I'm just gonna make this. You can see how bad I am.
Why aren't you using a list comprehension?
Somebody
Why are you
asked
writing
that?
for loops? No, that's just me.
Oh, okay. Good. As long as there's nobody. None type has no attribute. Oh. Oh, sorry.
Seth says great stream so far, guys. Thanks,
Who
Seth.
is that?
I don't
Oh,
know them.
somebody is. Oh, sorry. Somebody's looking at a live stream. Interesting.
We have 7 people looking at the live stream. I don't know why.
Oh, you guys must not have anything to do in lockdown. For path and zip. Wait, what am
Correction,
I
it's
missing?
8 people.
Okay, let's see. What am I missing? I'm passing in my axis. So for path, comma x, shouldn't that just work? If I go, oh, did I not? Oh, I didn't do that, did I? So that should work. Let's see that. Oh, okay, image none type. But I am passing x. Oh, okay, I see. That's a silly mistake. All right.
That should work.
Yep. Only it doesn't show. Okay. What if I just say plot? Would that work? Don't even need my x. I always get stuck with this kind of stuff. Like, I need to learn more matplotlib.
I just use Plotly because like that's more hackier than this, at least for me.
Let's see if that works. Huh. Okay, I'm not gonna spend a lot of time on this. Like, I've spent way too much time and I've embarrassed myself way too much to just check if there's duplicates in this. So, good thing is it's not gonna be recorded anywhere, which
Yeah,
means I can just live with my embarrassment.
that's fine. I won't bring it up in our weeklies. Don't worry, Aman.
Oh, thanks. Yeah, don't let anybody at work know that this is how bad I am with coding. They'd fire me. Okay. And that. All right, so pretty
I
much
mean,
after 20.
I'm no expert, but they look the same to me at least.
Yeah, and after 20 minutes of just ignoring, well, just spending time on doing nothing, now we can
Yeah.
see we've just been able to confirm that there are duplicates in our computation. So this is what I did terribly wrong. I did not remove duplicates. Okay, that's the first thing. The next thing is stratified group k-fold. Okay, I know what that is. That's cool. There we go. So now what people have done is they used, yeah, see, that's the thing. That's what makes things different between a top 5 solution. So I pretty much got tired of, like, I had one model in study, I had one model in binary, and I had 2 models in detection. But the difference is between rank 5 and rank 131 is they have 11 models in study. They have 10 models in binary because it's 2x
Yeah.
5-fold. So that's 10 models. And they
And
have
25.
25 models in detection. So that's the difference. I guess that's what, and they have different image sizes. Yeah, I thought of doing this, but I was like, there's other, yeah, that's where I failed. Okay, that's next time I'm going to try and do more and more Ensemble. So I guess this is what it says. We used an ensemble of 11 models. The architectures are efficient at V2M, efficient at V2L, B5, and B7. Models were trained on different image sizes ranging from 512 and 720 and different augmentations. I really wish they provided code.
I think they have. So that's just the inference kernel. Sorry. Hmm.
Okay, I'm just gonna ask and post here. Models were trained on different image sizes and different augmentations. Segmentation as Ox loss
I'm
suggested by Hank.
curious.
Okay,
What
this is
is
cool.
this?
Okay, I will explain. Just give me a minute. Segmentation as Ox loss. So segmentation as Ox loss. So you get that, and then you get that, and then get that. Interesting. I will try and explain. I don't really understand exactly, but I will try and explain on what's going on here. We
Sure.
will go to that discussion first. And when I was first read it, I was quite excited, but like I kind of I've just recently learned about auxiliary losses. Uh, Auxiliary losses is just this idea of
So I'll tell you what I understand, and you can correct me if I'm wrong. So when you're doing transfer learning, you add an auxiliary loss, and you use both. You essentially account for both the losses when doing that. Is that what this refers to?
come again. Sorry, I kind of
Sorry.
missed that. I just
Yeah,
got a message from home.
I wasn't clear from that. When we're doing transfer learning, we just use this like original loss on which the model was trained, and then add an auxiliary loss. Is that what this refers to?
When you're doing transfer learning, no, I think okay. I think this is a bit different. Like my understanding is with auxiliary loss, you have a like you if you're trying to do classification, you also do segmentation, but then that segmentation in itself becomes your auxiliary loss.
I see.
Uh, that's just yeah. I think that's the idea of like I know we're trying to do study classification, but because there's bounding boxes already, so we can get the masks, which means we can make the model do segmentation as well. So the idea, I guess, is now I have to go back and confirm to that. I think that's the part we'll go to that forum post
Sure.
by Henk.
Grandmaster Heng. Yeah.
Yeah, Grandmaster Henk. So we'll go and have a look at that forum post on what exactly this is. But my idea is, I guess you also add like just segmentation, which is
I
just
see.
extra loss. So the model learns some more interactions, I guess. All right.
Hmm.
V2 models used a custom PCAM pool head.
V2 is referring to efficient net V2, I'm guessing.
Correct, correct.
Okay.
So what's a PCAM? PCAM points to check chest expert, which is just a uh, let's see, chest expert, which is just a data set. So user hidden test set, what the cloud include, data preparation. That's okay. That's okay. I'm just trying to see PCAM. So let's see PCAM. There we go. PCAM is what is PCAM?
Currently
Currently
supported
is
global
supported
pool
global
options.
pool. Okay, so you have average pooling, you have max pooling, there's exponential and linear pooling, average max pooling, and then PCAM is a type of pooling. I see.
Interesting. I
PCAM
will
is a
look that up real quick.
about PCAM pooling.
Yep.
Uh, oh, here it is. Probabilistic CAM pooling. There's the paper. Weakly supervised lesion localization with PCAM pooling. I see. That's something new. I have never heard of this. Let's
Yeah,
have
I
a
found the
look.
paper as well. I'm going to drop it in the chat for
Yeah,
the
this
eight
could make a
people
good
watching.
paper reading group.
There you go.
Yeah, that's what happens. There we go. We could look at PCAM. Actually, another one is weighted box fusion, but don't worry about it for now. Let's see. We don't need this anymore. So where are we with? That's taking a bit long to open a PDF, isn't it?
Archive is always slow for me for some reason. Yeah, maybe they don't like me reading papers.
Well, maybe you read too many papers and they're like, slow
I
down, man.
I, I think I just waste too much time, so they're like, no, you shouldn't be doing this.
Weakly supervised lesion localization with probabilistic CAM pooling. So what is it? Localizing correct
Asif is
diseases.
asking, tell us more about segmentation mask with org laws. I think we'll just discuss this when we read the post by
Yeah,
thing.
and could you actually say, yeah, that's a good thing. Could you monitor the live chat so that way we
Yeah,
know? Keep doing that. I think that's it.
I can show the comments like this as well. That's really cool.
What's that?
That's just the
See,
comment I was reading.
oh, okay. It says we present probabilistic class activation map pooling, a novel global pooling operation for lesion localization with only image level supervision. Okay. Explicitly leverages the excellent localization ability of CAM. So do you know what CAM is, right?
Yes.
Yeah. So CAM is just this idea of like using attention, and then you can pretty much. So if I go to that, oh, there's only 10 references in this paper, so it's not a very massive paper.
Hmm.
Interesting. This is the first paper I've read with 10 references. Pretty much all papers I read have like 50 or
I never look at
okay.
the references. I just like scroll. At that point, I'm scrolling really fast.
Oh, right, okay. I do have a look at the references because I think it does help to understand like where things are coming from. So experiments on the chest X-ray 14 dataset show this, and this is the repository that has PCAM pooling, shows how visual examination on the probability maps generated by PCAM pooling shows clear and
Oh,
sharp
I think
boundaries.
this is the paper by the same author of the repository we were just looking at.
Yeah, yeah,
I'm guessing.
yes, yes. So I believe these guys would be the main people behind the chest X-ray or the chest Chexpert dataset,
Yeah.
right? And then they would have also invented this PCAM pooling when they would have been trying on Chexpert dataset. So there we go. You have like a probabilistic map based on that. So you get, let's have a look at this image. So you get your backbone, you get your feature map,
Right.
you do average pooling, so you'll get one feature embedding, correct?
Hmm.
And then you have
Fully connected, followed
plus
by sigmoid.
sigmoid. So this gives you the probability of disease and then your weights. Okay, I don't really understand what's happening. Okay,
Yeah.
maybe let's not spend too much time on this, but we can. This is something I'm gonna bookmark,
I think it's
add to my
open
reading
source as well,
list.
so I'm sure they would have it in the code as well in
Yeah,
this
yeah,
server.
they would. So I think it this makes a this actually makes uh
Model. Yeah.
there you go, global pool, and there it is, PCAM pooling. Okay, so you just have your logit map, and then based on that map you do a sigmoid, which means every pixel in a way is going to get a weight between 0 and 1.
Correct.
So then your weight map becomes this, oh, by the sum. Why would you do that? Okay, I don't understand. And then you just multiply a feature map with this. Okay, I've got to have a look at this. This is something, it's a simple idea. Like in terms of lines of code, this is like
Yeah.
how many lines? Like 14 lines of code.
it's
So
it's
I
less
think it's
scary
a
than
very,
that image.
yeah, totally. So we can, this is something we can have a look at later. So let me also add this to my reading list. Interesting. Code is in my reading list. That's life. Okay, so they used V2 models. So this would be part of the segmentation ox loss, right? They would have used unless they use this for classification. That's not clear. Okay, I'll have to ask. We can ask. Sam, can you remind me? But let's just see. So far, we need to ask about like what augmentations they used and
Yeah.
the configurations, and we also need to ask what's this for? Like, is this just for classification? Can you use PCAM pooling for classification? And then they use B5, B7 multi-head attention, I would believe. Concat pooling. Concat pooling is average and global pooling. And then attention suggested by Kaggle master Tavara from
Hmm.
Yokohama. Okay. We also use noisy student training. Okay, so noisy student is fine. Noisy student shouldn't be a problem. Uh, but we can have a look at this. That's fine. Noisy student is fine. And then they use horizontal flip TTA. So there's only
Test
one
time
TTA.
augmentation. Okay.
All right. So this solution then, questions that we have, questions. Let's see if somebody else has asked that already. So this is single models. Okay.
Hmm. We wanted to
Congrats,
ask them about the
everybody,
Oglos.
on a strong finish. That's just common courtesy. But now let's just ask the question.
Let's bother
uh,
them now.
yes, let's bother them. We're being
Uh,
nice to them. Nobody's nice without a reason. Uh, could we please ask if you questions being study?
First was the Oglos.
Grammarly says this is wrong. I shouldn't use please here. Uh, and then we're gonna ask V2M regarding that. Regarding PCAM pool head on V2. Is that for classification or segmentation? All right.
Hmm.
And then they said V2M model as actually trained on full class study. We use the negative predictions as none and merge these with the binary predictions from the above. Oh, sorry, I'm reading something else. Don't worry about that. Okay, so I guess that's study. So I guess then the idea or the overall summary of study is we have 11 models. There's different architectures, different augmentations, different image sizes, using segmentation and like different pooling from they're using concat pooling and they're using PCAM pooling and they're using attention in there and they use the noisy student. If I remember correctly, in noisy student ImageNet, you pretty much training a network and you keep
I'll be
increasing the
back in a
size.
second.
Oh, no worries. Present noisy student training with semi-supervised. That works well. Semi-supervised. When label data is attendant, if noisy students use 88.4 on ImageNet, just 2% better. Okay.
I have my
Requires.
box running at full speed, so like I need the AC on all the time now.
I see. Are you training models
Yeah.
in the background?
Yes.
Interesting. Always. Better than state-of-art model that requires. Okay, so they have 3.5 billion weekly. Noisy student training extends the idea of self-training and distillation. On ImageNet, we first train an efficient model on labeled images. I see. And use it as a teacher to generate pseudo-labels for 300 million unlabeled images. We then train a large efficient net. I see. Aha. Okay. Okay. During the learning of the student, we inject noise via rand augment. I see. Okay. So that's a really massive way of doing things. Let's see what that. Uh, so do you know what noisy student is, Sam, or do you want me to quickly explain that?
Please do. Please explain. I have
Uh,
a idea, but I need a recap.
yeah. Okay. So in noisy student, what you do is, see, ImageNet is 1.4 million images. As I understand from the abstract of this paper, you train a model on 1.4 million images. That model becomes your teacher. Then you predict on 300 million unlabeled images. So see how they say on ImageNet, we first train an efficient model on labeled images and then use it as a teacher to generate 300 million pseudo labels on 300 million unlabeled images. I think that data set would be 300 million. Would that be Instagram or not? I'm not exactly sure what the data set is. Maybe that could be the JFT 300 million. I'll have to double check, but that's fine. We can ignore that. So then it creates that 300 million unlabeled images and it uses those unlabeled. So now you have labels for pretty much these 300 million and you have labels for the 1.5 million, right?
Yep.
So you have labels for 301.5 million images. So far, so good.
Yep.
Then
Makes
you
sense.
create another model on these 301.5 million images. That becomes your student. Does that make sense?
It does.
And then you predict again on the 300 million images, and you keep doing this over and over again. Does that make sense, or is it too
It
confusing?
does. It does. It does.
Okay, cool. So that's that. So let's see what happens. So this is Ranzer. So a lot of the solutions could be actually looked at from Ranzer, because that was using that was pretty much classifying on tubes on chest X-rays. So that was again chest X-ray classification. So a lot of ideas could be used for classification, like they have used in the study classification here. So let's see what the idea is, and it's like a 6-layer solution. I will publish the kernel first and then write the solution later. For this
Achilles, I would
computation,
say that just like comes with a lot of experiments. So like
what
even I was curious. Do you
what is
not see
that?
the layover? Like I've highlighted the comment.
Oh, I'm not even looking at the chat.
Oh, sorry. So Achilles is asking how do people decide with what architecture to use and how many models will be suitable. I was just saying, like, I think it comes to experiment. Like, I was also curious how did they decide what to do with the efficient V2 models and the B models. And I'm guessing, like, they must have tried and, like, through the local validation checked what's working better, and that's how they arrived at that.
Yeah, and there's generally like a fixed standard of models that you want to use. Like efficient nets are going to be there. Efficient net V2 is always going to be there. With the vision transformer is generally going to be a part of the ensemble. Like generally from what I've seen. Um, MLP mixer, maybe not so far, but that could be one. I don't know why. Actually, you won't use MLP mixer, but there's like this some set of models that have performed really well, and they aren't really hard to train. And efficient nets being one of them.
Hmm.
Uh, they'll always be part of an ensemble, I think. But this is a subjective question. Like you won't have an answer. There's
Yeah.
no straight answer. There's like yeah, you can find. It's more trial and error, as you said.
I think efficient also are like pretty intensive on the training requirements. So like for people using kernels, they might not be using it as much. I'm guessing. Again, I might be wrong.
I see. Hmm. So that's the noisy student trick. Every time I finish training k-fold, which means you finish your fold 1, 0, or 1, 2, 3, any, uh, you generate out of fold predictions
Predictions, soft labels.
and use those soft labels to train the model in the next cycle, which makes sense. This boosts my local CV and leaderboard scored quite a lot, and I think it's the reason I can get. I see. Okay, that's a. Okay. So basically, if this is my data set, I can divide it into like let's say 4 folds: 1, 2, 3, 4. Then you can train your first model on this, predict on this, you can train your second model on 2, 3, 4, predict on this. You can train your third model on 1, 3, and 4 and predict on 2, and you get the idea, right? So
Yeah.
then in your next model, you use the labels, which are the outer fold predictions. So for my first model, which was trained on 1, 2, 3 folds, I can make the predictions on this fourth fold. And
Hmm.
similarly, now I will have like predictions for my whole data set. Does that make
Makes
sense,
sense.
AM?
It does.
Okay, cool. And then that means that I have predictions, I have soft labels, and then you use the soft labels. So there's a lot of research about soft labels actually. With soft labels, like uh, your model generalizes better. And the reason why, actually, I was just looking at this in few days ago. That makes sense. With soft labels, what happens is your model doesn't become overconfident.
Hmm.
Uh, so say have you heard of label smoothing?
I have, yes.
I think it's the
I
same
think you
idea.
taught this, so I was in that lecture.
Yeah, it's the same idea. Label smoothing. Let's see. Label. For anybody looking at label smoothing, this is the
But
idea.
from
Where
my
did I
under
teach
what
this? Was it from Fast Book Reading Group?
I think so, yes.
Yeah, okay. So label smoothing is this idea. I think what happens with label smoothing is like instead of having your labels as ones and zeros, you have labels like these. Oh, sorry, not that. Where are my labels? You have labels like this, like your 0.92, and then all the others get 0.02. So your model
Hmm.
never actually becomes very confident or like overly confident of its predictions. And then
Hmm.
it generalizes better on unseen data.
Makes sense.
I see. There's like lots of tricks. I'm really happy that I'm doing this. Like I'm reading the solutions and
Yeah, I guess what
it's
they've
so
done
just
for the noisy student trick is just like instead of
yeah,
using the ImageNet examples, they're just using out of fold examples, right?
yeah, yeah. Pretty much. Like you, all you do is you have yes, you have outer folds. So that's the trick. We're still wondering what this is. Oh, sorry, we're still wondering what PCAM is, but we can move ahead.
Yeah.
So then the binary or non-class predictions. Okay. So giving background on what's happening is like I had my study, I had my series, and I had my SOP, right?
Mm-hmm.
So this list of SOPs become my images, and for
Right.
each of them, I have a bounding box, right?
Yeah.
So similarly, I could have a list of images for my studies because they've said ignore, like get rid of duplicates, right? Which means
The
each
duplicates would be in the
study,
SOPs, or would they be in the study?
or they would be in the study because you'd have multiple, like you could have one study with a series with multiple SOPs, right? The X-ray, like you could have multiple SOPs in a series.
Makes
So
sense.
you
Yeah,
could you
that
could
makes
have
sense.
multiple SOPs. Like when I do this, I'm actually doing like study series SOP, and then you have like
Hmm.
again study series SOP and SOP. So that's where the
Right.
duplicates would be. So that's like three different studies, right?
Right.
Um, now, because we don't have to worry about duplicates, that means that for each study, I still have one image, right?
Mm-hmm.
Does that make sense?
It does.
Which means I'm gonna have 6334 images, and I could also say that I'm gonna have 6334 studies, right? It's the same
Yeah.
image, like the same images. The images are just
Makes
gonna be
sense.
the same, but I could have my 6334 images, and I could have 6334 studies, right?
Yeah.
For the studies, because we want to classify labels like these ones, when I was looking at the data, where is it? For the studies, for studies, all you want to do is you want to classify it into like these four different labels, right? So you have four
Mm-hmm.
different labels: one, two, three, four. Let's say like negative for pneumonia, whatever those labels are, negative, typical, whatever, right? Let's not worry about
Right.
what they are called. So I want to classify these into four, which means I could use these 6334 images to just do standard classification, like just multi-label
Got it. So
classification.
that's where the classification is coming from. I just assume it was
Yeah.
just bounding boxes and
No,
masks
no,
there,
no.
but
That's where the
that makes sense.
classification, right?
That
And
makes
then
sense.
for each image, pretty much for each image, because you have a bounding box, right?
Mm-hmm.
You could then do detection, which is like using your object detection.
Got it.
Uh,
So we could ensemble both
then
of those models and
not ensemble, you just pretty much concatenate them. Like in your final prediction, then you have for each study, then you get a prediction of the label, and for each image you get a prediction of the bounding box. Does that make
hmm,
sense? So like
that
your
does.
final would be 12 668, right? That's how many 12,668, because out of these 6334 would be studies, and
Hmm.
again 6334 would be images, right?
Right, they're
But for the
separate. Makes
images,
sense.
you're predicting bounding boxes, and for the studies, you're predicting labels. Does that
That
make
makes sense.
sense?
It does.
Okay, because that's what you have to do in this competition. Like if you have a look, like that's what they'll say. So if I go overview evaluation, you'll see that for my studies, I'm predicting like negative or that stuff. And
Hmm.
then for my image, I'm predicting my bounding boxes. Does that make sense?
That does.
Cool. I would be surprised if that didn't, because then I would be doing a pretty bad job at explaining it.
Or maybe I'm just
Uh,
like very slow with it.
oh no. Uh,
Luckily, I'm not that slow.
luckily you're not, and luckily you can correct me when I'm going wrong.
Hope
So
so.
so then the idea, what they did was, so here's the idea. Okay, this is really, this is the first time I've ever seen something like this. It's
Hmm.
like I have my 12K, out of which 6K are studies and 6K are images, right?
Right.
Now, I could use a 6K classification into four classes, 1, 2, 3, 4. So that's done, right?
Hmm.
For the remaining 6K, which are my images, right? There could be images that don't have a bounding box. Does that make sense?
It does. Yeah.
Okay. So how about this? For each of these 6K, for each image in these 6K, I predict my bounding box, which is like 4 coordinates, X, Y, W, H. And for example, a single image could have multiple bounding boxes, right?
Yeah.
And I could also predict the class. Like when I'm predicting X, Y, W, H, I'm pretty much saying that COVID is present in this image, right? So the class is, I'm saying like the class ID is 1 for each of these, right? Does that make sense? My class
It
ID is
does.
1. I'm just saying like, okay, COVID is present, therefore my class ID prediction is 1, and this is the bounding box. Then I'm saying like second prediction is, okay, COVID is present, but this time on the left lung over here. Does that make sense?
Yeah.
Okay. But it's also possible that image does not have COVID, right? In that case, you want to predict 0 as my class ID, and your XYWH pretty much becomes like 1100 or something like that. I think it's just like 0011. Oh, it's yeah, it is 0011. That's defined in the evaluation. Like in that case, you just
Makes sense.
uh, predict that. So I'm just going back to data. So see there, if it's none, you just go 1011. That's what it
Right.
says.
That makes sense.
Anyway, so it's just saying like, so yeah, some prediction. Okay. Uh, and the class IDs are wrong. Like in the actual competition, if the thing is actually present, that class ID is 0, and for the class ID 1, it's like 1. Just the class IDs. Anyway, but you get the idea, right?
I do. Yeah.
So what people did was for this 6K images, you train a 2-class model, none, or let's just say COVID, right? So then this becomes my first classifier, which says, okay, out of these 6K, I think anytime where there's, you know how we could do this? Like from the 6K in the ground truth, we could grab all those images that have bounding boxes, right?
Yep. Yep.
So I get my data set of like 4K have COVID, 2K no. So I could train my classifier on this, which becomes this 2-class classifier. So they're just talking about this 2-class classifier in,
Interesting. Got it.
yeah. So that's the binary prediction. Okay. So it's the
Someone's
same
asking
idea.
if this will be available on the channel afterwards. I don't think so. Like this is just an impromptu discussion, honestly.
Yeah, I don't think so. This is just Sam and I actually spending time with each other, and you guys are part of the party, I guess.
Fortunately or
Um,
unfortunately.
yeah, fortunately or unfortunately, you've decided to listen to us. But I guess we'll be more prepared in the coming sessions. I don't even know actually if there's going to be sessions. This is just
Yeah.
something, as Sam said, we had too much chai.
This is what happens when that happens. So now you
Yeah,
know.
Sayam joined Weights and Biases, and then he made me have a lot of chai,
And now
and
we're
this
live
happened.
streaming on YouTube.
Yeah, which took 40 minutes just to find how to live stream, by the way. Okay, so we in this one they used an ensemble of, well,
10
5-fold models,
models.
just two models. So this one and this one, but 5-fold, all on 512 image size. They use segmentation as aux loss. They use this custom pan pooling, custom PCAM pooling. B6 was trained using the pipeline provided by Heng. Okay, a lot of people have used his starter kit.
I don't know
And
if he still does it, but back in the day, he would like prepare a
starter
starter
kits.
pack
Yeah,
and
he's
like
still
a
doing it.
very nice PDF slide
Yeah,
deck along with it,
yeah,
so that like you don't
yeah.
even need to figure out how to set the paths. Like,
He's doing it. He's still doing it. He's really
yeah,
cool, and you know, deserves to be Kaggle Grandmaster in every sense.
yeah.
And there's a lot to learn from him. So the V2 model was actually trained on 4-class study data. Okay, interesting. We used, okay, that's an interesting idea. Do you see what they've done?
For class study data, they use the negative predictions as none and merged those with
Yeah.
the binary prediction.
Do you know what they've done? Does this make sense, Ayam? Think.
Uh,
I will give you a hint. So my study predictions are these.
okay, yeah, now it does. Now it does.
Okay, tell me.
So from those four, which is like a different classification, if they get a negative,
Mm-hmm.
they just merge it into the binary predictions where it's just saying no. Is that right?
Correct. Absolutely. So see how from these 6K images we said COVID is not present or COVID is present, right?
Mm-hmm.
What they did was they used the negative. There's like a negative from the study label. They used
Mm-hmm.
this label because it's the same images. Like these 6K images are pretty much the same images, like just twice. You're just training them with different labels. Does that make sense?
It does. Yes.
So I could grab the negative predictions and that becomes my none. Like if the image is negative for pneumonia, that just means there's no COVID present. Like that's what they've
Mm.
assumed.
That makes
Um,
sense.
okay. Oh, I don't want to go to forums.fast.ai right now. Sorry. I'll come back. And then they used high horizontal flip. So I guess we're again stuck with. We had a look at custom pool, PCAM pool, but we're
Yep.
still gonna not stuck. But this is just something we've got to look at segmentation.
Sounds good.
All right, and then this is easy. They just use like these efficient debts for training. They use like different image sizes. Where one of them was a rectangular image, which is pretty cool. Only on opacity predictions, and then they
I'm
use
just curious, like
WBF.
how do you decide like what size to use with what model? I know it's like just experiments, but like
Yeah.
intuitively, how do you?
Um. So YOLO X was a bigger model, which means you're
Hmm.
going 620. Well, it's the same, or you're going 620 compared to efficient at D5. I don't know. I don't have an answer for this.
Yeah, I mean, like
I think
if
you
you
could
want to
look at
do,
the. Oh, sorry. You go.
sorry, I was just saying like if you want to do better, like just spin up more instances and train on bigger images. Ideally, like that in theory at least that would give better results. But I don't know.
Yeah, and I think one thing that's part of this is like uh you could look at the original models and see what image sizes they were trained with. So I could go back and have a look at efficient at D3, and I could look at the configuration. I could see, okay,
That makes
this
sense.
model was pre-trained on 640 by 640, so maybe I should just use that image size.
That
Does
makes
that make
sense.
sense?
Yeah.
Yeah, that's just the idea. And then they use this really cool trick WBF, which I used as well, so I know of it. It's just this idea of merging bounding box predictions from these uh, various detection models. So what's going to happen is like,
So how do you do that? I'm
yeah,
curious.
good question.
Do you just like average them in a way, or
No, there's a much needed trick. Like you use confidence from each of these. Like I won't go into the details, but I'll just
okay?
say there's this weight. I think if we go into the details, that would take another 1 hour or something. Um, but pretty much you see like you have your boxes list. So if you have two models for the
Mm-hmm.
same image, the first model predicts like these boxes. Oh, sorry, if you have one image, then the first model says, okay, there's like 5 boxes in that one image, and the
Mm-hmm.
second model says, okay, there's like 4 boxes, right? The first model gives scores or like the confidence for the boxes it
Okay.
predicts over here. The second model also gives scores,
Mm-hmm.
and then the first model also gives like labels. It says, okay, this box is class ID 0, this box is class ID 1. It does the same thing. Like the second model says, oh, the first 3 are class ID 1 as presented here, and the last one is 0. And then you can just call weighted box fusion, which will kind of mix the two. And if you are interested, as I was when I first started with this, because I was really mesmerized by the solution. You could. Oh, I did. I just come back to the same place.
I
I did.
think you did. Yeah.
Sorry, I meant to go to the research paper. This is what happens when I'm a bit tired. Uh, if you go and read through this paper, you will see like how they, as you can see, I've read through this paper in the past. But when that opens, you'll see like there's like a step by step on how they combine the various
Makes
predictions
sense.
and
Okay.
how that looks like. Okay. So that's that. So then you can use that WBF. And then in the pseudo label training, D3 was trained with exponential moving average. And okay, that's pretty hard to do unless Ross, I think Ross would just provide EMA easily. Let's have a look.
Hmm.
Uh, let's see EMA. Yeah, there we go.
Oh,
Uh,
it's there.
oh no, there it is. Model EMA averaging. You just say model EMA. Yeah, I would be surprised if Ross didn't make it really easy for us because he
Hmm.
always makes things really easy for everybody. So they use EMA, And YOLO v5 were trained with a few none images as well. That's fine.
Interesting.
D5 was trained. Okay, and then was trained with EMA. Pseudo-labeling did not bring any. So pseudo-label. Okay, so what you can do is like you can train a model, and then you can use the predictions to train the second model, right? That's the
Right.
pseudo-labeling. Um, but you would need to have a bigger data set to do pseudo-labeling. So I guess that becomes a question. So the question is, oh, they generated pseudo labels on the public test. I see.
Okay.
Interesting. Cool. This is really an eye opener for me. So Sam, you know what they did? Can you try and summarize?
Yep, they're just using the predictions. Like they're making predictions onto the test. So like for people who don't know, Kaggle provides this test set where like which is the public leaderboard. They just made predictions on that and then
Yeah,
did the EMA training on them. Sorry, the
correct.
D3 model was trained on that with EMA.
Yes. So EMA is just this idea of exponential moving average. As in, as you go and you train epoch by epoch, you still
Mhm.
keep the weights from earlier epochs to some weight. Like
Interesting.
the
Okay.
first epoch could be 0.01. If you want to read about this, read about what exponential moving average
Oh, who's
is.
this guy? I've heard
I
of him,
don't
I think.
know. I don't know who that is. But he writes a bloody good blog post at times.
Yeah, I
Uh,
heard someone say that.
yeah. There we go. What is exponential moving average? You could have a look at this for anybody who's interested, and you can see how you can do model EMA in PyTorch. And as I usually do, I've copied the implementation. Cool.
Is the score
Uh,
learned? Someone from the chat. I don't think so.
so you can see. Oh, sorry. Just gonna finish exponential moving average.
Yep.
Um, So this is the easiest way to understand exponential moving average. Sayam, this is more for you, I guess,
Hmm.
because you
Hmm.
and I we're partners. So Adam sells lemonade. Let's say on day one he sold 5, on day 2 he sold 3, right?
Yep.
The average would be 4, right?
Hmm.
But
Yep.
let's say my given decay factor is 0.99, which means my which means I want to give 0.99 uh, weight to my more recent weights, and then I want to give 0.01 to my previous weights. Does that make
So
sense?
0.99 to day three and the
Plus
1
zero point zero 0.01 times
minus.
5. Yeah, zero
Right. Makes sense.
point zero
Yeah.
0.01 times 5. So which means my older epochs, as I go, 0.01 times 5, and then as I keep going, it's just going to be 0.01, zero point zero 0.01 square, 0.01 cube, which is just like a geometric progression.
Makes
That's
sense.
just the idea of EMA. It's like you
Makes
still
sense.
have some weight from earlier epochs.
But just like a really small amount.
Yes. Like you could change the EMA factor. Like you could make it 0.5 or like, you
Hmm.
know,
Makes sense. Got it.
but it makes sense to have the latest epoch weights because that's the model which has learned the most.
Right.
Does that make sense, Sam? Do you
It
have
does. Yes. Thank you.
no problem? Uh, okay, so D5 was trained with EMA. So the labeling did not bring any improvements as we did not include them in the final ensemble. Okay, so that's it. I guess, and then inference you use WBF. Uh, So I guess that's it. We just need to understand
The Heng
ox loss
approaches.
segmentation, and then we also just need to have a look at this. I think that's the two things that we need to look at. Did I already comment my question? I did not. Right. Okay.
I
Never
think you
mind.
did. You didn't? Okay.
Let me refresh. Maybe. No, I didn't. I wrote it somewhere, and then I did not comment.
I
Okay.
remember doing that. You doing that.
Regarding comments in the first place. Oh, somebody's asking about EMA. I can. This would be a good time to just self-market and put that there. Anyway, so then that's the inference kernel. We'll release our full code as well. Okay, perfect. I guess that's when would be a good time to again meet and have a look at that full code because then that make
Yeah,
things
sure.
easy. I guess we can stop here today
Hmm.
and uh, either I can take a break for an hour and we can come back and study again, or we can meet in a few days' time. I think let's meet in a few days' time.
Yeah,
Same. We can be more planned, and we can have these like daily sessions. We can have this as
sure.
daily
Why
sessions.
not? Yeah.
Cool.
Awesome. Thanks. Thanks for doing this, Aman.
No
I'm
worries.
going to. allow me to drop Aman's blog in the YouTube chat so that everyone, I'm sure they know who you are, but they should know you, who you are in case they don't. One moment.
Oh, Sam, you're being too kind to me. But thanks. All
Just
right,
make
I'm
sure
gonna head
you
off.
pay me like we agreed after this is done for doing that.
Absolutely. And then you pay me for promoting chai time,
That's the deal.
which means we don't pay each other. All right, I'm gonna head off with that poor joke.
Awesome.
See you guys and gonna have some dinner. Bye.
Bye, Aman. Thank you.